Here's your video about fractions, decimals, and percents, which are three different ways of representing a number. It's important for us to understand the fundamental relationship between these three ways of writing a number. It helps us really make sense of the numbers that we see around us all the time. But the bottom line is about these three numbers, they all pertain to a part of a number. Now, what do I mean when I say a part of a number? We're going to use this box right here as our one whole that we're going to be cutting up into pieces so we can look at parts of a number. This one whole could be one whole math class where most of the students are women and some of the students are men, or a class where almost half of the students have a full-time job, some have a part-time job, and the rest are looking for a job. Or it could be your weekly paycheck or monthly paycheck or bi-weekly paycheck, where you figure out what part goes to your rent, what part goes to food, what part goes to your bills and credit card, cable TV, and cell phone bills, what part's going to a car if you have one. The rest, hopefully, you can save. Maybe you buy a TV, or maybe your pipes burst and you need to have emergency work done on your house. But we're looking at different ways of taking one whole that we would divide up into smaller pieces. And when it comes to working with decimals, fractions, and percents, we're specifically talking about taking this one whole and first cutting it up into equal-sized pieces. If we take that one whole and cut it into two equal-sized pieces, we are beginning to have a fraction. The denominator would be the 2 to represent we've cut our one whole into two equal pieces. And if we chose to work with just one of those pieces, that would make our numerator become the 1. And we see this familiar looking 1/2. We can see from our diagram we've shaded in 1/2 of the figure, but remember the denominator is how many equal pieces we have. The numerator is how many of those pieces are we actually working with. We could cut our one whole into 4 equal pieces. Now we're dealing with fractions that would have a denominator of 4. The numerator would represent how many of those fourths, how many of these individual equal-sized pieces are we trying to work with. Shading in 3 of those fourths, we'd have a 3 in the numerator. 3/4, so 3 out of 4 equal-sized pieces. And those pieces together represent one whole. I want to point out that it doesn't really matter the shape of those pieces as long as they're all the same size. Here I've cut our one whole again into 4 equal pieces. They're not all rectangles. Well, none of them are rectangles, but they are all the same shape. This sort of shallow L shape. 1, 2, 3, 4 of them, and they're all the same size. So definitely, again, we've got a fraction that has a denominator of 4. And if we chose to work with 3 of those pieces, it doesn't matter which 3 we pick, but we've just picked 3 out of 4. So again, we're looking at 3/4 of the whole. Here we've taken our one whole and cut it into 5 equal pieces. Denominator of 5. And what would the fraction be if we choose to work with that? We've just chosen 3 out of our 5 pieces. We're looking at 3/5. Now the denominator can be any number that we choose. It just means that's how many equal-sized pieces we have to make up the one whole. We'll also look at some more examples where we divide our one whole into 10 equal pieces. So we're looking at tenths, a denominator of 10. If I wanted to represent 4/10, I'm just going over and shading in 4 of these pieces. 4 of those equal pieces, and we had a total of 10, 4/10. Here's the last example I want to throw at you of cutting it up into equal-sized pieces. Now we have 100 equal-sized pieces. And this is important because this is what we want to think of when we're talking percent. Percent really means out of 100 or divided by 100. So anytime we're looking at a percent, we know that it is a fraction out of 100. What percent would we be looking at with this diagram? Now remember, 100 equal-sized pieces, and if we count them up, we've got 10 on the bottom row, and then another 8 to make 18, 19, 20, 21, 22, 23. So it's 23 out of 100. We can definitely see that from the diagram. And to call it just 23%, means that automatically the percent is out of 100. So you see a percent, and we know that percent means out of 100. We'll talk about this a little bit further later on, but now I want to point out something that's important for us to know about fractions, especially about equivalent fractions. Here's one whole pizza. This whole pizza, we're going to cut it into 2 equal-sized pieces. Now, since we've just made 2 equal-sized pieces, we know we have a fraction where the denominator would be 2. Now I'm going to eat one of those pieces, so we've just dealt with 1 out of those 2 pieces. We have a fraction 1 over 2, and definitely we can see we're looking at half of a pizza. 1 over 2, 1/2. Now what if I took a pizza and cut it into 6 slices? So now we have 6 equal pieces, so we have a fraction with a denominator of 6. Now consider if I were to eat 3 of those pieces. So we've got a numerator of 3, and it looks exactly like a half of a pizza. One more quick one. Here's one that was cut into 8ths, 8 equal slices, and we've got a fraction with a denominator of 8. I'll go and eat 4 of those pieces, so a fraction 4 out of 8, and again we're left with half of a pizza, and we've eaten half of a pizza. Well, I've eaten it. What I want you to see about these numbers is that there's a way using calculations to actually show that these are all actually equal to 1/2. And because this 1 over 2 uses the smallest numbers, we like to say this fraction is simplified, or in lowest terms. So they all represent the same amount of the pizza that's been eaten, half, half, half. We just changed, well, how many slices did you start with, and how many of those slices did you eat? So the calculating that we want to show is, if you start with the 1/2, and you multiply your numerator and the denominator by the same number, like if we were to multiply both of them by 3, we will get another equivalent fraction. That's how we can come up with that 3 over 6. If we took the 1 over 2 and multiplied both the numerator and denominator by 4, it always has to be the same number to top and bottom. We'd come up with the 4/8, another fraction that equals the same, really, part of the whole, half of the whole. And it works for multiply, and it works for divide also. Like if we started with 4/8 and said, let's divide numerator and denominator by the same thing. If we divided them both by 4, we could come back to a 1/2. And that's a way that we can simplify fractions, to put them in their lowest terms. If we can find numbers that we can evenly divide out of numerator and denominator, we are simplifying or reducing the fraction. So this is an idea that we will see when we start looking at converting between fractions, decimals, and percents. Now we've got a good basic background of fractions. The denominator is how many equal pieces in the whole. The numerator represents how many of those pieces we're working with. So now let's talk about relating fractions to percents. We've got this diagram cut up into fourths, 4 equal pieces. And let's think about dealing with just the top piece. So we're dealing with 1/4. Now I'm reminding you of our diagram for percent, where we have 100 equal pieces. And I'm going to overlay this diagram of percent, 100 equal pieces, onto our diagram of fourths, 4 equal pieces. So I filled in just our top fourth of those small percent boxes. And if we count them up, we will count 10 on the first row, 20 on the next row, 21, 2, 3, 4, 5. So we're looking at 25% is the same as 1/4. Let's show this idea with what we know about equivalent fractions. We started out dealing with 1/4. Out of 4 equal pieces, we chose the top fourth. Now looking at it cut up into percents, we found a total of 25%. We know that as a percent, it's a fraction that always has a 100 in the denominator. Now we work in this idea about equivalent fractions. What can we multiply to 4 to get up to 100? 4 times 25 will equal 100. Now if we do the same thing to the top, another multiply by 25, 1 times 25, we see 25 out of 100. So they are equivalent fractions. They both represent the same piece out of the whole. The 1/4 is in lowest terms, and the 25, because it's over a 100, that's equal to a percent, 25%. So as soon as we can see a fraction that has a denominator of 100, we know it's a percent. And whenever you see a percent, we know we can write that as a fraction. Just put your number over 100. A quick way to go from percents to fractions, as long as our denominator is 100. It might take a few more steps to try to simplify this fraction. What can we evenly divide out of numerator and denominator? And 25 is the biggest number that evenly divides into 25 and 100, and it takes us back to that 1/4, the same portion, but in simplest, in lowest terms. Let's do another similar example. So keep in mind this diagram of percents, because we have 100 equal pieces. And now let's look at a fraction of fifths. Now let's choose our bottom 1/5, and we'll fill it in with those percent squares. So how many of those percents make up 1/5? We can count these rows are 10 and another 10 to make 20. And if we show it numerically, starting with a 1/5, what can we multiply to 5 to get up to 100? Well, we multiply the 5 by 20, so let's multiply the 1 by 20. We have an equivalent fraction, 20 over 100, and as soon as it's over 100, we know that that's a percent, 20%. Now, if you're starting to think about, well, how do we come up with what number do we multiply to get up to 100, I'll give you a few basic multiplication facts that you should memorize that will be helpful in terms of dealing with fractions and percents. And they're all different ways that we multiply numbers to get up to 100. So let's start, of course, with the 1 times 100. We'll just get that simple one out of the way. 2 times 50. 3, we don't have one that works evenly, but we can do a 4 times 25. 5 times 20 is a useful one. And the last one we have is 10 by 10 is 100. Our original diagram of percent that had 100 equal squares was 10 columns and 10 rows. So 10 by 10 to give us a total of 100. Here's maybe a good opportunity to work in the money example, because I really like going to that example when it comes to dealing with percents. They really do go hand in hand, the money example with decimals and percents. So some things that I want to know, like 4 quarters is $1. That's my 4 times 25 is 100. 5 times 20. Well, it's interesting to know that 20 nickels would make up a dollar, so that's one way to think 5, so 25s or 20 nickels is $1, or just think $20 bills. How many do you need to have 100? If you happen to have 5 in your hand, then 5 20s is 100. I like when that happens. It's not that many days when it does. And based on what you see here, there are definitely some fractions that don't work into a percent so easily, like 1/3 would be what out of 100? We don't have a whole number that we can multiply by 3 to get up to 100. It's actually 33 and a third. 3 of those would make 100. So 33 and a third, this is a pretty funky looking fraction, but I'm only doing it to show that if we wanted to come up with a percent, it would be 33 and a third percent. So now we'll start to look at the relationship between fractions and decimals, and percents and decimals. And there we'll see a way to handle some of these numbers that we don't know how quickly we can get them to be multiplied up to 100. So fractions that have a denominator of 1, 2, 4, 5, 20, 25, 50, all very quick and easy for us to get them into a new fraction over 100, and there's your percent and your fraction. So now let's start looking at decimals as maybe a way to handle these fractions where the denominators are 3, 6, 7, 11, etc. Decimals and percents are very closely related to each other. Here's our diagram of one whole, and one of those boxes is 1/100th, or 1%. So as a fraction, we've got 100 equal parts. We've shaded in one of them. Since we have a fraction over 100, we know we're talking about a percent, 1%. Now, because 100 of these squares makes up one whole, when thinking about percents, it's helpful to think about it being like a scale from 100 down to 0. So from 0, 1, 2, 3, 4, etc., all the way up to 100. So 95, let's go to 98, 99, 100. So when we talk percents, we're thinking, well, what is it on a scale of 100, with 100 being our entire grid, one whole. So 100% is really one whole. All the way down at the bottom of the scale is 1%, that one box out of 100. In the middle, directly halfway, is where we would see 50%. And we just showed how 50% equals 50 over 100, which equals 1 over 2 as a simplified fraction, all different ways to represent 1/2. So comparing the percent scale to the decimal scale is really a way to put things on a scale from 0 to 1. So what numbers would we have in between 0 and 1? The way to, I think, closely see the relationship between the two is to call this one whole 1.00, like $1. So going down, we'd see 0.99, 0.98, 0.97, like 99 cents, 98 cents, 97 cents, all the way down till we get to 5, 0.05, 04. Remember, make it look like cents because these are out of 100, so 0.02, 0.010. Let's even stick a 0.00 there. So here's where we can see the relationship between decimals and percents. They're really talking about the same kind of a scale, except one's from 0 to 100, the other's from 0 to 1. The quickest way we could go from one scale to the next would be to move the decimal point. So as a decimal, here's our decimal column. If I took my decimal point and moved it 2 places to the right, so that my point ends up back here, now we have a percent. So did you get that? I like to think of the this is silly, Dr. Pepper method. So to go from decimal, the D for decimal, to go from decimal to percent, I can see I'm moving the point 2 places to the right. And if I started with a percent and wanted to turn it into a decimal, that would be moving the point 2 places to the left. So that's the Dr. Pepper method to let me know decimal to percent is moving it to the right, percent back to decimal is moving it to the left. So if we're talking about 50%, what would that be as a decimal? Move it 2 places to get to 0.5 or 0.50. Halfway, so as a decimal, 0.50, as a percent, 50%. As a fraction, we can call it 50 over 100, and we can simplify that to be 1/2. What about an example? Let's put it right here. Let's say right there we have 30.2%. So what is that as a decimal? So instead of it being on a scale from 0 to 100, we're looking at a scale from 0 to 1. We have to make this into a decimal number. Move that point 2 places to the left, and we'd get 0.302. So it's very quick for us to take any kind of percent and change it into a decimal. It's just a matter of moving that decimal point 2 places. And it's helpful to think of percents on a scale from 0 to 100, and the corresponding decimals are on a scale from 0 to 1. And if I even look at my one whole as like a 1.00, I can really see these decimal numbers that match up with the percents that we have. And since we have such a quick way to go from decimal to a percent, let's talk about how we can go from a fraction to a decimal. And then we'll very easily be able to take a number that's a fraction and change it into a decimal, and then write it as a percent, and take a single number and write it 3 different ways: percent, decimal, and fraction. Now I want to go back to looking at fractions very briefly to look at this connection between decimals and percents in a little bit of a different way. So let's talk about 18%. We know that 18% means 18 out of 100. And this fraction right here, with the 100 in the denominator, is basically making us think of this scale of 0 to 100. The percent scale, basically. Since it's out of 100, we know it's a percent. Percents are on a scale from 0 to 100, and 18 would be somewhere toward the bottom, but not too close to the bottom. Now, we know about equivalent fractions that we can multiply or divide the same thing to top and bottom. And I'm going to choose to divide top and bottom by 100. The reason I'm going to do that is because, looking at the denominator first, 100 divided by 100 equals 1 whole. So this denominator that's 1 whole is starting to have us consider this decimal scale of 0 to 1. The denominator does tell us this range that we have to work with. The denominator was 100, so we're thinking from 0 to 100, where does 18 fit in? But now that the denominator is 1, we're talking about a scale of 0 to 1. Where would the numerator fit in now? Well, 18 divided by 100. Let's not focus on doing this by hand, but on a calculator, or if you happen to know what dividing by 100 does to decimal numbers, we can see that we'll come up with a 0.18. So it's basically the same spot on this range. If it's on a range from 0 to 100, it would be 18, but if it's on a range from 0 to 1, it would be at 0.18. Remember, we see like the 0.7s up here, then 0.8 and 0.9, and going down we'd get a 0.1, 0.09, etc., low, 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 down to 0. So our 0.18 fits in right here, pretty much like 18 does on a scale of 0 to 100. So in a sense, we could say that we're taking this fraction and coming up with an equivalent fraction, making the denominator equal to 1. So we end up doing 18 divided by 100. And that's one way that we could show why we actually, when it comes to changing a fraction to a decimal, we do numerator divided by denominator. 18 divided by 100 gives us 0.18, and that's the way that I like to go from a fraction to a decimal. I won't be focusing on doing this move by hand. We'll talk about doing it on a calculator, and eventually we'll talk about what we should really know when it comes to multiplying or dividing by tens, hundreds, thousands, 10,000s, etc. Now we've gone through a lot of talking and background information. It's time to actually try a few of these problems, and what could be a very familiar looking table to you, where we get a number that's either as a ratio, also known as fraction. Let's just write that in there, same thing. A number that's either a fraction or a decimal or a percent, and we have blanks to write it in the two other forms that are missing. So we're going to use all the information we've talked about to hopefully pretty comfortably go with all of these answers, and even see a few interesting examples that take a little extra detail work. Let's start with 58 over 100. Can we write this as a decimal and as a percent? We should recognize, first of all, that since it's over 100, it is in percent form. That is a 58% all the way. How would we write it as a decimal? We've got a few ways we could do it. We could remember about moving the decimal point. We could remember that we're thinking not on a scale of 0 to 100, but 0 to 1, so the 58 would be a 0.58. And if you are good with place values, this is 58 hundredths. So we're looking to put a 58, so the 8 is in the hundredths place. Tenths, hundredths, 58 hundredths. A few different ways we could come up with our answers there. Let's go to our next one. Now we're starting with a decimal, 0.07. So again, we can use what we know about place values. This is, the 0 is in the tenths, the 7 is in the hundredths place. So 7 hundredths. That's got to be 7 over 100. Or we could say, I know to go from a decimal to a percent, I'm moving the decimal point 2 places. So ending up back there, behind the 7, we're looking at a 7%. And now that we know 7%, we know that's 7 over 100. So lots of different ways to go from one number to another. And it might feel some ways are easier than others at times, but go with what's working for you. We definitely would like to understand and appreciate all the different ways we could do it, but go with what's making the most sense to you. Now 450%. This has gone way above 100%. So if you think back to our diagram where we had one whole and then cut it up into 100 small squares, all equal size, and that's definitely not 100 there. Since that's only 100, we would need to have a second for 200, a third to make 300, a fourth to make 400, and then a fifth one for our additional 50%. So 450% has actually put us well above one whole. It's put us at 4.5. You could see the same thing if we think move the decimal point, moving it 2 places to the left to make 4.5, and there's our 4.5. As a ratio, lots of different ways we could do it. You might know 4.5 is 4.5, and that's great. You could write 4.5. As the improper fraction, it would be 9 over 2. You could go back to your percent and say 450% is 450 over 100. Now, percent is always over 100. And here we could do some simplifying. Put this fraction to lowest terms, we would eventually get to 9 over 2. Lots of different options. Now we're starting with a ratio, 9 over 1,000. Let's do the divide. 9 divided by 1,000, and we get a 0.009. The same thing you would think of if you said, well, this is 9 thousandths, so tenths place, hundredths place, thousandths place. There's the 9 thousandths. Once we have it as a decimal, just moving it 2 decimal places to get our percent, 0.9%. So hopefully things are feeling somewhat comfortable. 0.83 as a decimal, so as a percent would be 83%. And we can write a percent as a fraction, 83 over 100. Lastly, 22.5%. Now we know percent means a fraction over 100, but 22.5 over 100 is not always thought to be the best form. We don't really like to have a decimal number in a numerator or a denominator. The quick fix is to say if I multiply by 10, that's a way to move the decimal point one place to the right, and just do the same thing to the denominator as you do to the numerator. So we end up with 225 over 1,000. And now that we have it as a fraction, a quick divide to get this into a decimal, 0.225. Or you could say I'll move that decimal point 2 places to the left and also come up with 0.225.